morning. In this session, we evaluate the contact process, namely the large-scale manufacture of sulfuric acid. The term contact process is derived from the fact that during the large-scale manufacture of sulfuric acid, sulfur trioxide gas is not allowed to come into direct contact with water. Instead, it is first dissolved in conc sulfuric acid to form oleum, and then oleum dissolved indirectly into water to form the required product, which is sulfuric 6 acid. And that is the bone of contention as to why we refer to it as the contact process. Now, to enable us to produce sulfuric acid by the contact process, we need some raw materials. The first, of course, is sulfur. And sulfur is used mainly because we do not have the oxides of sulfur occurring naturally. They have to be produced by burning sulfur either in excess oxygen or under limited supply where it forms sulfur dioxide. When in excess supply of oxygen, it forms sulfur trioxide. 2, the air is for the purpose of oxidizing the sulfur. 3, concentrated sulfuric acid is used in the contact chamber to transform sulfur trioxide gas into oleum. And 4, the water is used in the solution chamber to dissolve the oleum to form the required sulfuric 6 acid. As you can see above here, we have the flow diagram made up of 7 distinct chambers. However, the main reactions happen under standard conditions, which we refer to as the optimum conditions. These optimum conditions are the conditions under which the highest yield of product is produced using the least possible effort and taking the shortest time duration possible. What are they? First, we need to fix temperatures at 450 degrees Celsius, optimum condition. 2, we need to fix pressure at a range of 2 to 3 atmospheres. And 3, we need a catalyst of vanadium pentoxide. In the absence of vanadium pentoxide, we could use platinized asbestos as the catalyst in the process. Let's then look at the flow diagram. In the flow diagram, you can see primarily we have sulfur as the main agent coming into the first chamber referred to as the burner. The aim of the burner is to sublime the sulfur solid by heating it intensely at its boiling point, and in this case 444 degrees Celsius, where sulfur changes into its gaseous form. Once sublimed, the sulfur enters the refinery where it meets excess oxygen gas, and in the refinery the aim is to purify them from particulates and other impurities. Now, once purified, the sulfur dioxide gas is not yet sulfur dioxide. The sulfur and oxygen are transferred into the compressor. Within the compressor, we expect sulfur dioxide already, and in the compressor, they are subjected to high pressure of 2 to 3 atmospheres just to enable the effective interaction of molecules of sulfur dioxide and oxygen gas. Remember, at this point, there is no synthesis because there is no heat. Now, as we proceed, sulfur dioxide and oxygen gas are transferred to the heat exchanger, where the temperatures are fixed optimally at 450 degrees Celsius. At this point, there is effective interaction between the sulfur dioxide and oxygen gas, and potentially there will be formation of sulfur trioxide gas. However, since the process is slow, we need a catalyst, and that is fixed in the catalytic chamber, which is infixed and works together with the heat exchanger. Now, as we heat and catalyze, the reaction between sulfur dioxide and oxygen produces exclusively what is known as sulfur trioxide. Now, the sulfur dioxide is again passed through the heat exchanger just to check its stability, that indeed it is unchangeable as sulfur trioxide gas. Remember, some gases remain unreacted. Now, once the sulfur dioxide is confirmed, it is transferred into the contact chamber, where instead of meeting water, it meets conc sulfuric acid, and it's transformed into oleum. Once oleum has been formed, the unreacted gases from the contact chamber are transferred back to the compressor, and the cycle continues just to produce a subsidiary composition of sulfur trioxide, which again is put into contact with the concentrated sulfuric acid to form oleum. The final step is the dissolution of oleum in water in the solution chamber. So oleum meets water in the solution chamber and precipitates what is known as dilute sulfuric acid, in this case the product in the contact process. Next, we are going to look at critically what are the chemical reactions that occur in the contact process. Otherwise, we have described the contact process as a process for the large-scale manufacture of sulfuric acid, that it is named contact process simply because the sulfur trioxide gas, which is the main agent for producing sulfuric acid, is not allowed to come into direct contact with water, in the sense that when it comes into direct contact with water, it forms misty sulfuric acid, which is hazardous and will lead to the formation of acid rain. Instead, it is dissolved in concentrated sulfuric acid to form oleum, and then oleum indirectly dissolved in water to form